Okay, so in today's class, we'll see how to do the conversion from given grammar, that is CFG, to GNF. Okay, Grayback normal form. So we started with this yesterday. Okay, how to convert a given grammar into its equivalent Grayback normal form. We solved some simple problems yesterday. What we'll do today is to take a little complicated problem, one or two, and solve them. So rules that we have to follow when we make the conversion is first to convert a given grammar into its equivalent CNF, okay, Chomsky's normal form. So we have solved some problems on that, so you should be familiar with that, okay, where you remove epsilon productions, you remove unit productions, you simplify the grammar, etc., and then you get it into a Chomsky's normal form. The second step is we'll rename the variables. This is an optional step, but we do rename the variable to ease our next two steps. Okay, so renaming is, for example, if you have like something like this, A derives BC and B derives CD, something like that, instead of keeping it like that, we are going to number them. Okay, number them. So B is nothing but A2 now. I have numbered B as A2 and C has renamed it as A3. So B is A2, A2 is A3, and maybe A4. This is done for some reason. The reason is, you can see next step. Okay, we use substitution methods to obtain the productions. Okay, to obtain the productions in this format. That is, always you see here A1 derives A2. So that means here I is less than J, correct? So we should get every production in that format. That is, the left hand side should be less than the right hand side. Otherwise, I am going to change it. Okay. So, and if left recursion is there, we are going to remove the left recursion. And we'll continue doing this step 3 and step 4 until finally the grammar is in Grayback normal form. So what is Grayback normal form? We saw that it's something like this, right? So a non-terminal which produces a single terminal followed by a set of non-terminals, right? And also something which may generate just a non-terminal. So this is an epsilon-free grammar. So let us take the first problem. Convert the following grammar into GNF format. So this is our first problem. So S derives AA or 0 and A derives SS or 1. Okay. So if you observe this grammar is already in CNF. Right? It's already in CNF. So what is CNF? Where a non-terminal derives two non-terminals or a non-terminal derives a terminal. These are CNF. So you can see here a non-terminal is deriving two non-terminals, right, in both cases, or they are deriving the terminals. So this is already in CNF. So first step is already complete. So let me move on to second step. And second step we talked about is renaming. Okay, renaming the variables. So how do we rename the variables? So I will rename S as, okay, I'll call S as A1. We have only two non-terminals here. I'll call S as A1 and I'll call A as A2. Okay. So if I rename, then the productions become like this. A1 derives A2, A2 or 0, and A2 derives A1, A1 or 1. So we have renamed it. Now after renaming, right, so you can see this is the equation that we have got. Now, but this is not in the format. The third step told us that the productions should be in this format, like AI derives AJ, where I should be less than J, correct? So of course, the production, I'll call this as production A and production B, okay? So the production A is following the rule because 1 is less than 2. So that's okay. What about production B? Production B is not following the rule because A2 is deriving A1 and 2 is not less than 1. Okay, 2 is not less than 1. So what we'll do is we'll use the substitution rule. What is the substitution rule? That is, in place of A1, you replace whatever is the right hand side of A1. So now A2 becomes, instead of, only for the first one, okay, only for the first part. So what A1 is, it is A2 or 0. So I will rewrite that as A2 in place of the first A1, and then the second A1 will be held as it is. Okay, and it also has 0, right? So 0 and the second A1 will be maintained as it is, or 1, which is its own. Now if you see here, A2 is deriving A2. So this is left recursion. And we cannot have left recursion in the grammar. So we have to remove left recursion. There is a formula that we apply to remove left recursion. Okay, what is the formula? Let us say you have productions of this format. A derives A alpha 1, A alpha 2, let us say up to A alpha n, or beta 1, beta 2, up to some beta m. The meaning of this is, see, you might have A deriving A. So you may have some terms with left recursive portion, and you may have some terms which do not have any recursion. You can see here A2 derives A2. This is left recursion portion. So here this part after A whatever is there, this will be alpha 1. If you see this part, there is no left recursion. So this becomes beta 1 and there is no left recursion. So this we can write it as beta 2. Okay, beta 2. So what does the rule tell me now? How do I remove the recursion? So I will rewrite this one. If anything is in the form of A alpha 1, A alpha 2, etc., I will rewrite them, okay, using this. I will write A derives beta 1 A dash, beta 2 A dash. A dash is some term that you are introducing newly. It can be A dash X, Y, Z, anything, okay, and beta M A dash, right? And what is A dash? A dash will be these alpha terms, alpha 1 A dash, alpha 2 A dash, like that, right? Alpha n A dash and n epsilon, and then epsilon, okay? So we are going to convert it into this format. So what was that we had here? This is where the left recursion is. I have already marked alpha 1, beta 1 and beta 2 for you. So I will rewrite them as A2 derives. So beta 1 is 0 A1 and I have to introduce a term. Let us call, I'll call it as X instead of A dash. I'll call it as X because A dash and A, some confusion will be there. That's why. Okay. And the next beta term is beta 2, 1. So 1 A dash, right? So 1x. And what is x now? X is equal to alpha 1 A dash. So alpha 1 is this term, A2 A1. So A2 A1x or epsilon. So as we already know, you cannot have an epsilon, right, in the grammar. Yesterday in the definition time itself, I told you that the grammar the GNF is always an epsilon free grammar. So that means I have to remove epsilon. So what is X is deriving epsilon, right? So I will rewrite A2 like this. A2, once I will substitute epsilon for that x. So it becomes 0A1, correct? And just 1. I have substituted epsilon for this x. And second time, I will substitute this term for x. Correct? I substitute this term for x. So it will become 0A1 x and 1 x. Correct? I hope this is clear. I kept it as it is once. I kept it as it is once and I have applied epsilon once. And if you observe this, this is already in GNF, Grayback normal form. So we are okay with this. See, a non-terminal followed by, sorry, a terminal followed by non-terminals or a terminal followed by non-terminals, terminal followed by a non-terminal. Correct? So this is already in GNF. Now what about this x? Again, I have to remove this epsilon from here. So x will be, right, A2A1x, A2A1x, or if I substitute epsilon for this x, then it becomes just A2 and A1. Okay. Now what happens is, if you observe, what are the productions now we have? I will rewrite, okay, so that we don't forget. Currently, what are the productions that we are left with? If you see here, first time, right, the A was okay, I said, no, it's in CNF format, I said, S derives AA. So when we renamed it, it became this, no, A1 derives A2, A2 or 0. So that will be one production. So what was that? A1 derives A2, A2 or 0. This will be my one production now. Okay. And the second production we wrote in these terms, that is A2 is equal to 0A1 or 1, 0A1 x or 1x, correct? And this is already in GNF format. Next one is x derives A2A1x and A2A1. Okay. So this is not in GNF and this is also not in GNF format. So this we are happy with. It's already there in the GNF format. So how do we convert the other things into GNF format? Okay. It's quite simple. Now A2 is in GNF format. Right? A2 is in GNF format. So just substitute A2 over here. Then you are going to convert everything into GNF format. Okay. So let me call this as A, B and C. A is already in, B is already in GNF. Now if I take the production A, I am going to substitute A2 in RHS. So now A1 derives, for A2 I will substitute all this, no? So 0A1, A2, A2 is whatever is left with, 1A2, then 0A1xA2 and 1xA2. Okay. So in place of A2, I substituted 0A1, retained this A2. I substituted 1 for A2 and retained the second A2. I substituted 0A1x for this A2 and then I retained this A2 and 1x I substituted for A2 and I also retained this A2 and this is 0. So I will carry it forward. So this you can see is in GNF now, right? So terminal followed by non-terminal, terminal followed by non-terminal, terminal followed by non-terminal, terminal followed by non-terminal or just a terminal. So now this is also in GNF. B is in GNF, A is also in GNF. Now for C again, substitute A2, right? Substitute A2 for the C production. So when I substitute A2 for C production, you can see once I will be retaining this and once I will be retaining this for each term. So let us take the first term A2 for A2 0 A1 and what I will retain here A1x, correct? So A1x. So x derives 1. Again for this itself I'll substitute 1 for A2 and what will I retain A1x, correct? And I will substitute 0 A1x for A2 and I'll retain this x, right? A1x. And I will substitute 1x for A2 and will retain A1x. Also, for this also we have to do. That is substitute this and just retain A1 after that. So, 0 A1 A1, 1 A1, 0 A1 x A1 and 1x A1, correct? So it's quite simple here, A1x and here A1, so you just have to drop the last x, that's all for the second set, okay? So this is also now in GNF form. So we have converted the given grammar into GNF format, okay? So this is one problem. Let us see one more problem, okay? So the second problem is convert this following grammar. A derives BC, B derives CA bar B, C derives AB bar A. Let us convert this into GNF form. Again, you can see that all of them are in CNF. Usually, even in exam, mostly when they ask you to convert it into GNF, if they ask, they'll be giving the grammar in CNF format itself. Otherwise, it becomes a very long problem. That's why. Anyway, so all productions are in CNF format. So no need to convert. Okay. The second step was renaming. So let us call A as A1, B as A2, and C as A3. Okay. So that means now the first production will become A1 derives A2, A3. Second production becomes A2 derives A3, A1 or B. And the third production becomes A3 derives A1, A2 or A. Right? Now you can see this first two productions for third step. If you see the first two productions, both these productions are in the required form. What is the required form? AI derives AJ alpha, where I should be less than J. So here you have 1 and 2. So it's already in this format. Here you have 2 and 3. So it's already in this format. Only this one is not in format because 3 is greater than 1. Correct? This one is not in format. So how do I do the conversion now? Again substitution, right? So because you have this as A3 derives A1, A2 or A, this A1 I am substituting with the right hand side of A1, right? So now it becomes A3 derives. So what is the right hand side of A1? It is A2, A3 and then this is A2 or A. But again, if you see, the left hand side and right hand side still don't satisfy the rule of I needing to be less than J. Here I is still greater than J. 3 is still greater than 2. So what do I do? Here we substituted for A1, correct? Here you substitute for A2. Substitute for A2. So what is A2? It is A3, 1 or B. So I will rewrite this as A3 derives A3, A1. For this A2 I have substituted once this part. Let me call it as X and Y. So X I have substituted. And what is left after that? A3, A2. And once I have to substitute this B. So B, A3, A2 or A as it is. Okay. So now if you see this particular equation, it has recursion. It has recursion because A3 is deriving A3. So it has a left recursion and we have to remove left recursion. To remove left recursion, this will become alpha, this will become beta 1 and this will become beta 2. If you have forgotten, alpha is the term which is left after you have the left recursion term. So A3, and because of this A3 you have left recursion, so remaining terms become alpha. And any term which is derived from A3 and does not have recursion, left recursion, they become betas. So what is the formula for removing the left recursion? Okay, to remove the left recursion, if there is an equation of this format, A derives A alpha 1, here only one alpha is there, so I'll just write it as alpha 1 and beta 1 and beta 2. If we have this, okay, then we will rewrite this as A derives whatever is there with beta will take first. Beta 1 introduce a new term and beta 2 introduce a new term, correct? And that new term will be alpha 1, the new term itself, or epsilon. So one line will be replaced with these two lines. Okay, one line will be replaced with these two lines. So coming back to our production, this one, so will be rewritten as A derives beta 1x, so beta 1s B A3 A2 x, right, bar beta 2x, beta 2 is A, so Ax, and what will x become? X will become alpha 1x. So what is alpha 1? A1, A3, A2. So A1, A3, A2x or epsilon. So as we know, epsilon cannot be there, so I have to remove that epsilon. So how do I remove the epsilon? Wherever x is there, you keep that term once as it is, and once you apply epsilon to that term. So here x is deriving epsilon. So the first one will be keep once as it is, A3, A2x and Ax, and once you write it without x because x is epsilon. So B A3, A2 and A. Similarly for this x also. So x derives A1, A3, A2x or A1, A3, A2. Okay, A1, A3, A2. Now, if you observe, let me rewrite all the rules again. Okay, this was not A, it was what? A3, correct? 8. Okay. So let me rewrite all the terms. We already have two terms here for A3. And what was the term for A1 which was already in CNF format? So we wrote the three equations here. A1 derives A2, A3. So A1 derives A2, A3 will be as it is, right? This was my first production. This was my first production, and second production was also in the CNF format. And what was the second production? Second production was A2 derives A3 A1 or A3 A1 or B. A3 A1 or B. Okay. And the third production, we broke it into two parts by substituting and removing the recursion. This becomes 3 and 4. Now let us see if anything is already there in the GNF format. Yes, this is already there in the GNF format. This is already there in the GNF format. Is this in the GNF format? No. Is this in the GNF format? No. Is this in the GNF format? No. So you have to convert these three into GNF format. It's easy to convert this one first. Why? Because A3 is in GNF format. I just have to substitute A3 for this, isn't it? So I will rewrite 2 by substituting for A3. Okay, by substituting for A3. So what will it become now? The second one. It will be A2. Okay. And substitute for A3. What are the terms for A3? You have 1, 2, 3 and 4 terms for A3. So B A3 A2X and then follow it on with A1. Similarly, AX A1, correct? And what else is there? Something is missing, no? We are substituting for A3 and A2. Yeah, B A3 A2 and X, correct. After that, A1, yes, AX A1. After this, B A3 A2, B A3 A2, and what is left here? A1. Similarly, A1, correct? So these are the terms we have, and B I am going to copy as it is. Now if you observe, this is also in GNF. This is also in GNF. So now I have the second one in GNF, also third in GNF. Now it's easier to convert this because A2 is already in GNF. So we'll rewrite 1 now by substituting for A2 because A2 is in GNF. Okay. So you can see it's easy. Everything should be followed by A3. That's all. So A1 is equal to A2 followed by A3. Correct? So it's simple. B A3 A2X A1, that is the term for A2, and followed by A3. So just attach A3 to all these terms. A3, B A3 A2 A1, this term, and then follow it by A3. A1, follow it by A3, and B, keep it here, B, follow it by A3. Now you can see this also has been converted into a GNF. This is also in GNF. Finally, what is not in GNF? Only X term, that this fourth one. We converted this and this. So for fourth term, now you can substitute for A, correct? So for fourth term, you can see it is A1, A3, A2X and A1, A3, A2. This is not X. This actually I put it as wrong mark, not in term. Okay. So it's A1, A3, A2X and A1, A3, A2. So for substitute for A1. So if you take that fourth term now, X, you write A1 term, B A3, A2, X, A1, A3. AX, A1, A3, B, A3, A2, A1, A3, A1, A3, and B, A3. So these are for A1. And after A1, you will have to write A3, A2, X once and A3, A2 once. So A3, A2, X you have to write once. I'm just leaving the space. When you write, don't leave the space, okay? Between these, don't leave the space. Just for your better understanding, I'm leaving that space. A3, A2, X. And once more for all those terms, you can see after A1 you have A3, A2, right? So, or. Again, I need to write these 5 terms. B, A3, A2, X, A1, A3, AX, A1, A3, B, A3, A2, A1, A3, A, A1, A3, and B, A3. After that, I am just going to add A3, A2. So it's quite simple, looks lengthier, but actually if you understand it, it's very simple. Okay. So this is our final solution. Now everything will be in GNF format. Okay. So in the next class, we'll do the conversion from PDA to CFG, and then we'll move ahead with the actual syllabus which is there in module 4. These were required as prerequisites for module 4. Which one? CFG to PDA, which we did in one class, and then conversion from grammar CFG to GNF, which we have done today. And one more class I'll take PDA to CFG, and then we'll see about actual portion in module 4.